Right, let's take a look at exercise 8b2. So like in 8b1, we want to show that this equation is a solution of this differential equation here. So if we have y equals 3x cubed plus k, if we differentiate that with respect to x, we end up with the 3 times 3 is the 9, reduce the power by 1, and the k becomes 0. So we're left with 9x squared, which is what we're after over here. Now next we want to find the value of k, and we are given an initial condition when x is equal to 1, the y value is equal to 11. So what we can do here is replace 1 for x in our function here and 11 for our value of y over here. So we get 11 is equal to 3 times by 1 cubed plus k. So we have 3 plus k, therefore k must equal 8. Alright, second example, we are told that that is a solution of our differential equation, and we're asked to work out the value of alpha and beta. So once again, if we have y equals alpha cos t plus beta, we can differentiate that with respect to t, so dy by dt equals, now we'll end up with a minus alpha sine t plus 0. So this value here and this value here both represent dy by dt, therefore they equal each other. So we can now equate terms and we can see that alpha must equal -3. So now we need to find the value of beta. So we haven't used this information here. So that means the y value is 5 when x equals 3 pi and 2. So we can substitute that into that equation there. So we get 5 equals, alpha is now -3, cosine of 3 pi on 2 plus beta. So in that equation there, we can simplify, and we know that the cosine of 3 pi on 2, which is our angle down here on the unit circle, that has an x-coordinate of 0. So we get beta must equal 5. Third example, once again, we are told that this equation here is a solution to this differential equation. So let's differentiate the solution. So dy by dx must equal, now a ln x becomes a on x plus, and the bx becomes b. So we can differentiate that again to get the second derivative. So d2y by dx squared will become minus a on x squared. So what we did there was ax to the minus 1, that becomes minus ax to the minus 2 when we differentiate, which gives us our expression over here. So now we can equate terms. So I know that minus a on x squared must equal the value of 3 on x squared. So therefore a must equal -3. Now we haven't used this information nor this information here. So let's see if that will help us work out the value of b and c. So if I've got y dash of 1 equals 3, that means if I were to replace 1 for x in here, I would have a divided by 1 plus b must equal, and that is y dash, which equals 3. I know a, however, is -3. So I'll get b must equal 6. I haven't used the value of 4 when x equals 1 yet in the original function, so let's do that. So we end up with 4 equals -3 ln 1 plus 6 times 1 plus c. That's replacing the value of x for 1 and y for 4 in the original equation. So rearrange that and we'll get our value of C. So we end up with C is equal to -2. So C, B and A have now been determined. So those examples should help exercise 8B2.